The U.S. Army is in the advanced stages of planning for the early production of its next-generation vertical lift platform, the MV-75, a tiltrotor aircraft designed under the Future Long-Range Assault Aircraft (FLRAA) program. This aircraft is expected to play a central role in the Army's future air assault operations, replacing the aging portions of the UH-60 Black Hawk fleet and significantly extending the Army's operational reach, speed, and battlefield flexibility. The MV-75 is based on Bell Textron's V-280 Valor, a technology demonstrator developed as part of the Army's push to modernize its aviation capabilities under the broader Future Vertical Lift (FVL) initiative. The V-280 completed years of testing and accumulated hundreds of flight hours, providing a strong technical and operational foundation for the MV-75's transition into a deployable system. The Army selected Bell's design following a competitive evaluation and has since moved rapidly to align acquisition, engineering, supply chain, and training resources around this effort. A major aspect of the current effort is the Army's willingness to pursue a concurrent development and low-rate initial production strategy. Traditionally, U.S. military aircraft programs proceed through a linear path: early development, followed by extensive testing, and then full-rate production. However, in this case, the Army is laying the groundwork for Milestone C, its official production decision point, to occur before full operational testing is complete. This does not eliminate testing but allows initial production to begin sooner, reducing the overall time it takes to get new aircraft into the hands of operational units. This path is not being pursued lightly. Army leadership and program managers have engaged in deliberate risk reduction planning over the last several years to make this early decision feasible. Bell and the Army have already conducted a series of special user evaluations with digital and virtual prototypes. These events provided valuable feedback from pilots, maintainers, and Army aviation personnel, which helped refine the aircraft's human-machine interface, maintenance layout, avionics, and flight control systems. In addition, the Army has mapped out key design elements that must be mature before production and identified which capabilities, if necessary, could be temporarily deferred without compromising mission success. At the core of the program's confidence is a robust digital engineering and design effort. This approach has allowed Bell and the Army to identify, simulate, and validate much of the aircraft's performance before full physical prototyping. In parallel, a significant portion of the aircraft's technical drawings, over 3,000 individual design files, have already been finalized and released. These drawings cover more than 90% of the aircraft's systems and subsystems. This early technical maturity has enabled the Army to engage with its supplier base far earlier than in traditional programs. The scale of this supply chain effort is also notable. More than 5,000 individual purchase orders have already been placed, covering a wide range of components and assemblies. The industrial base supporting the MV-75 includes more than 360 vendors located across the United States. These companies are responsible for producing everything from structural components, flight control systems, hydraulics, and avionics, to specialized items like castings, forgings, and bearings. The Army and Bell have worked closely with these suppliers to ensure they are prepared to deliver quality components on time and at scale. This proactive supply chain engagement is paired with strict program requirements, including the Army's insistence on full right to repair access. This means, the Army will maintain the ability to repair, modify, and maintain its aircraft without relying solely on the original manufacturer for parts, tools, or software. This condition was established early in negotiations with Bell and is seen as essential to ensuring the long-term operational independence and cost efficiency of the MV-75 fleet. Beyond design and procurement, the Army has also focused heavily on preparing aviators for the transition to tiltrotor aircraft. While the Army has operated helicopters for decades, the tiltrotor design brings new performance characteristics, such as greater speed and altitude, as well as different handling dynamics. To begin building this expertise, the Army has arranged for its aviators to receive hands-on tiltrotor experience through cooperation with other units already operating similar platforms. This effort is underway at training installations and is intended to ensure that when the MV-75 enters service, trained crews will already be in place. The Army's planned timeline includes completion of the critical design review in 2026, which will mark the conclusion of the detailed design phase. The first physical prototypes are expected to be delivered in fiscal year 2027. If performance data and user feedback from these early prototypes are positive, the Army could approve low-rate production by fiscal year 2028. That timeline would allow delivery of a full company of MV-75s, roughly 24 aircraft, well ahead of the original schedule. A brigade-level fleet could follow approximately 2.5 years earlier than previously forecasted. Despite the faster pace, the Army has made it clear that it will not cut corners on safety or performance. Rather than combining developmental and operational testing into one phase, which has proven problematic in some past programs, the Army is opting for a staggered approach. First comes developmental testing alongside early production. Only after enough performance data has been gathered and analyzed will operational testing begin, ensuring that soldiers train and operate with equipment that meets defined performance thresholds. In parallel, the Army has worked with Bell to define what actions will be taken if early production aircraft exhibit unexpected issues. There are binding agreements in place that hold the manufacturer accountable for resolving problems, upgrading systems, and delivering aircraft that meet the Army's needs. These measures are intended to reduce the risk that early units become obsolete or require costly retrofits. The MV-75 program reflects a broader cultural and strategic shift within the Army and the Department of Defense. By leveraging digital tools, engaging industry early, and balancing risk with speed, the Army is demonstrating a new model for how complex military systems can be fielded faster without sacrificing quality or long-term readiness. This strategy also reflects confidence in the American defense industrial base and its ability to respond to ambitious modernization goals. In the long term, the MV-75 is expected to serve as the Army's primary medium assault aircraft for decades to come. Its performance will enhance tactical mobility, provide faster response times, and expand the operational reach of Army ground forces. Whether delivering troops into contested areas, supporting special operations, or conducting rapid medical evacuation missions, the MV-75 will serve as a central tool for future combat operations. The Army's decision to pursue early production will be closely watched across the defense community. If successful, it could serve as a blueprint for other programs seeking to balance innovation with urgency. The goal is not only to field a new aircraft but to demonstrate that with planning, discipline, and clear goals, American defense acquisition can adapt to the pace of future conflict.